All right, so back over here to the content. Like I said, I wrote lab 7. Do not do labs. You won't be doing any of the labs in zyBooks. If you want to do them for your own, they're open, they're there, do what you want to with them. But I'm not grading those. I am going to grade the chapter 7 lab that you see here. If you click on it, there's a Word document. You can download it and you can follow the directions. You should not try following the directions on that until I do some of the stuff in class today, because it won't make a lot of sense. Unless you've done Python before, then do what you want to. So we're going to do the PowerPoint, writing functions PowerPoint today. We might get into some examples today, might not. Depends on how long it takes to get through the PowerPoint. In class next time, we will do a full idle kind of demonstration where we're going to follow directions that are very similar to the lab you're going to do and build some functions and run things. So I'll record that also, so you'll have that to reference back to. Friday, I'll be in here to help you with the lab, or I will open up the video call. Somebody that's here on Friday to remind me to open up the video call on Friday where the online students can join us. But moving forward, I think you'll benefit more from me writing the labs than from the time you're spending trying to decipher what zyBooks is. Because I went through quite a few of them over the weekend, and it just seems like the way they're wording things makes them harder than they have to be. And from the feedback I'm getting from you guys, I feel like that you might be better off with some straightforward directions.
Ironically, what you came across.
Yeah. You remember my son is also taking this course with a different instructor. And when he brings me his laptop in frustration and he basically chunks it in my lap and says, "What are they asking me?" Then I get to see it on 2 levels. I see it as a parent, I see it you guys in class. I've heard it from several of you, and I've heard it from several of the online students that they're just getting bogged down in what they're asking them to do. So yeah, you can just sit there and keep forcing code at it until you get a perfect score, but I don't think you're learning as much as if you were doing something more independently, more straightforward. Now, that means that it's more grading on me. You're not going to get the instant feedback that you're used to on how well you're doing, because you're going to have to do it and then submit it. And hopefully me and Garrett, the TA, will get things back to you rather quickly, but be patient with me if I'm not. That being said, that's for this week. The lab will be done on your own. It's due March 7th, which is a week from today. I will get to this examples on Thursday of this week. Friday, like I said, we'll do what we normally do. Let's open the PowerPoint up. So we're going to talk about writing functions. You've been using functions. We just haven't really told you how you can create your own yet. So every time we've done a print statement or input, you've been using functions. So now we're going to talk about writing our own. Just a little heads up, project 1 will be posted this weekend. You'll have all of next week to work on it. Probably the same thing. I won't make it due till Tuesday of the following week. So you'll really have about a week and a half actually to work on it if you want to. There'll be no new content next week. You will just have the project. So in class, I'll do some stuff, and if we do stuff in class, I'll videotape it for the online students. But Tuesday and Thursday in class, we'll pull the project up. I'll answer questions, give you in-class time to work on it, and you'll get feedback from me. On Tuesday, I'll probably go through the whole spec with you and point you in the right direction. That being said, it is in 3 parts. If you do part 1, you'll get X number of points. If you do part 2, you'll get a few more. If you do part 3, you get some more. Do not move to part 2 or part 3 without having completed the parts before them. If you do all of part 1, you are guaranteed a 74, I think, is the way the points work out.
Done. You already done part 1.
I should say project 2. Project 2. I typoed again. I'm sorry.
It's index 1.
Yeah, you did project 0. Thank you, saving me there. Okay, so this will be the second project, not the first one. I'll change the slides later, maybe. But it's still in 3 parts. The last one had like 5, but this one has 3. If you do the first one, you should get a C. No problem. Absolutely, we'll get a passing grade if you do all of part 1. You can ask me any question you want to about part 1. You can ask Garrett, our TA, any question you want to about part 1. You can ask CSX questions about part 1, and they will help you. Part 2, you can ask me and CSX and Garrett about anything you want to. Part 3, you can only email me or catch Garrett if he's in class to answer questions. And the CSX lab students know this, and they will not help you with part 3.
Sure they know this.
Yes. I will double check, but yes, they know this. Why am I doing this? Because part 3 is the challenge portion of it, where I send you out to try to see what you can learn on your own and what you can find. Now, does that mean that you have no access to the internet during all this? Absolutely not. You're going to use the API and the help files and stuff like that. This is how much can you figure out on your own. I don't think you can go on our website and find this entire project written out for you to copy and paste. Unless one of my former students has done that. If they have, somebody let me know, and I'll go, we want to do it, take it down. But somebody's going to go, well, what if we cheat? If I catch you cheating, you will both get a 0. Like the person that did the code and gave it to the other person, as well as the person that copied the code. Now, this doesn't mean you can't help each other. This means that you can go to your buddy and say, hey, can you look at this and tell me what I did wrong? And they find your syntax error. That's perfectly acceptable. Do not do like my students last semester, where they copied the entire file of their buddy, including their buddy's name, and turn it in.
Oh, what? No,
I'm not kidding.
neither not for you.
That's like.
You understand why you don't do this?
So
That's like.
asking for help from your friend and going, I did it this way, without typing code for them or letting them copy and paste your code, is fine. But taking pictures of, copy and pasting, or just giving your entire code to your neighbor is not fine. I hate that I have to say that to college students, but it happened last semester.
Well, where does that catch up with you in this class if you just copy and paste? I mean, like, it's got to.
Well,
Just curious.
it does catch up to you because you have to move on to other courses. Also, every one of you all have a coding style. And I am much more observant than most people think I am. If your code is beautifully written, but you didn't understand what we did in class, I'm going to go,
Outside your realm of knowledge.
yeah, you've had a huge knowledge jump there, and I'm going to come talk to you. You know, subtly. I'm going to ask you questions and have you explain things to me. And if you can't explain your code to me, ding, 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 that makes me question. And I'm going to watch it a little more carefully. In my experience, and I hate to say this, people that cheat usually don't pick the right person to cheat from.
That's probably true.
Because most of you that are working really, really hard aren't just going to hand over your really hard work to somebody that's not. So, don't cheat. The only person you're hurting when you cheat is yourself. We have talked about the standard library, maybe not in the last class, but in some of the previous classes. Please be aware that it's there for you. Use it. Don't forget about it. We have introduced the turtles a little bit. I showed them to you in class last week. We're gonna do some of the examples we're gonna do. We've done for loops, we've done the range function in range for we talked a little bit about the drive principle. Don't repeat yourself. We're gonna talk about it some more today. We are gonna talk about refactoring code. You write really bad code that looks gross, got lots of lines in it, but it works, and then you learn something new and you go back and you fix it. That's refactoring it. Well, we may or may not talk about the accumulator pattern, and we'll see. So let's talk about functions and methods. Functions, aka methods, depending on which language you learn. If you learn Java first, you call them methods, like I do. These allow us to do specific tasks in our program, and especially things that are going to be repeated. It breaks things into segmented sections and allows us to build kind of like little blocks. So it's like building blocks of code. There are a lot of benefits to this. Say we wanted to draw 15 squares with our turtle on a screen. If we create a function called draw square, then we can put that in a loop and not have to write all the lines of code to draw the 15 squares, right? That saves us time, saves us typing, saves us typos, and fixing syntax problems. Calling it over and over again, it makes it plug and play. What you're going to learn about object-oriented coding is once you build stuff in one program, you can use it in another program. Because you built it, you used it. Why not take it with you into your future endeavors? We're not going to talk about them a lot here, but they do a lot of things called classes in object-oriented programming. Like Turtle is a class or a module. I could build things like that and then reuse them. So now I can use Turtle whenever I want to without having to reinvent all that code or rewrite all that code. You've been using functions, you just didn't know it. So when we want to use a function, we say we're calling the function. We're gonna call the function. It's going to then jump to that section of your program and execute each line of code in that function in order. So everything in computers programs happen in order, unless you call a function and then it jumps to that section and then it comes back. This is a lot simpler than when I learned to code and you actually had to put in go-tos and you had to tell what line number it needed to jump to. And then you had to return to the right line numbers. You had to keep up with what line number your code was on. It was messy. Because if you made any edits up high in your code and you had go-tos or jump tos lower down, you had to remember to go all the way through your code and change all the numbers. It was bad. It was tedious. Nowadays we have function calls, and then it goes and looks for where the function's defined, does those steps, and then it goes back to where it started from automatically. So it keeps up with itself. We are going to do these things sequentially, though. The steps are always going to be in order inside those functions. There are some constructors, which are special functions that we'll talk more about, that create things. Like the constructor for our turtle. When we created Alex, we called a special function, which is a constructor that created a turtle on the screen. There's also some other special functions and methods we're going to talk about. We call them helper functions. You have a long piece of code. It's got messy stuff in it. You got a loop inside of a loop inside of a loop. You can create a function to do some of the pieces of that and call it inside of there. functions can call other functions. So think of it like you're a little kid with your building blocks or your Legos, and you can take the little bitty Legos and put them together with a bigger Lego piece until you get whatever you're building. In my house, it's usually Star Wars Legos, bigger. But if you try to build that entire ship in one setting, it doesn't go so well usually. You miss things, you forget what you're doing, you get bored, you leave, you go away, come back. That's why if you look at your Lego, if you have those big Lego kits, that there's more than one set of instruction booklets. They compartmentalize it for you. You're going to build the landing gear. You're going to build the wings. You're going to build so that's kind of what functions do. We're going to do this. We're going to do it well. We're going to do one thing, do it well, and then pull that into our main program. So this is an example of a function. So this function operates in this order. You have the top line, which is the definition of the function. DEF is short for definition. So this first line says, I'm defining a function named move in box. And I have no parameters because I have empty parentheses. So I need no information to run. Then the lines of code inside are indented over because they belong to that definition. And they happen in the order you see them, the order they come to. Right? So if you're reading through this, with what little knowledge we know about turtles, and with the name we gave it, what do you think this function does?
Draws a square.
It draws a square. The turtle moved in a box shape. So functions can call other functions. So you'll see print called another function. You'll see draw square called inside of a function. You see all sorts of things. What that does when you see a function call, it transfers control of the program to that function briefly. It does those lines of code, and then it goes right back to the next line from where it started. And you're all going, why are you harping on this? Because it can get very confusing. So if you have these functions, we have one called draw figure, we have one called move and dash, we have one called turn left with a dash. So dash, by the way, gives you a dashed line instead of a solid line. If we're looking at this and we go through these in order, and we're in definition, or we're in draw function, or draw figure calls the down function from turtle, and then it calls move dash, which is down here. So this is going to go and put the pin down. Then it's going to jump from here and do these steps. But you get in here, it's going to go forward 10. It's going to pick the pin up. It's going to go forward. It's going to put the pin down. Right? And then it's going to go back up here to this next one. Turn left with a dash. Now it's going to go over here and do these steps. Oh, wait, it calls move dash. So at this point, I'm jumping back down here. Make that a little clearer for you. This is the order that those steps would go. Yeah, it's a little crazy. But we do step 1, step 2, jump to 3, which is down here at the bottom. Do 3, 4, 5, 6, go back to 7. 7 says, oh, I'm going over to 8. 8, 9, oh, now I got to jump back. I'm going to go down to 10, then I'm going to jump over to 11.
Flashbacks on your side mode animations, sorry.
I'm not animated, it's
No,
not
no,
animated at all,
good. It's good.
but I wanted you to, and this is a little convoluted, it really is. But I want you to see that functions can call other functions. And what they do is they continue down the line until they call a function. They jump over, do the code over there, and then they immediately go back to the next line from where they left. Cool. I like it when it makes perfect sense. If it doesn't make perfect sense, now's the time to ask me a question. I got some. Yes, sir.
What made it go from like 2 to 3?
So this is a function call, move dash with parentheses. That means we're calling a function. So it's going to look for where this function is defined. So it's going to look through the code and it's going to go, oh, there's the definition of move dash. I need to do the steps here in order before I go to the next line. Does that help? Other questions? Because if you're confused, somebody else is too. Okay. Email me if you come up with more questions. So functions are defined. This is the format for defining a function. You're going to use the keyword DEF for def, definition, whatever. You're going to give it a name. Generally speaking, I'm going to tell you to name it something useful, like draw box, draw square, draw rectangle. Something that clearly defines what the function is doing. Print. You know. The parentheses are always there. If the function needs information to run, like in print, it needs to know what it's printing, then it goes between the parentheses. If it does not need any information to run, you leave the parentheses empty. Now, when you're defining a function, you don't necessarily know what the information between the parentheses is going to be, so you give it a variable name. So if I was doing something for print, I might have print parentheses statement. And whatever I want printed will be put into that statement place. It's kind of like a holding place. And then it does whatever our directions are. And indents are important. If you don't indent it, it's not part of the function.
Is that something we have to remember and memorize, or does it, after you define it and everything, does it go into the automatic?
Yes, if you put the colon in the right place and hit enter, it's automatically going to indent the next line just like it does with the for loop or a while loop. So that's a good way of knowing whether or not you've left something out of the line before. If it doesn't indent the way you expect it to when you hit enter, then you probably have a syntax error on the line above it. So this one shows, I color coded it for you because, you know. So we're going to specify the function's name. We're going to specify what the parameters are. And functions can also return variables or return information, but we'll talk about that in a minute. So this example defines a function called display info. It takes two parameters. It needs a name and a message. That makes sense? It's then going to print hi and whatever's in name. And then it's going to print whatever is in message. So we did inputs before where we asked them to give first and last name, and then we printed first and last name. Similar thing, except the function's not doing input statements, it's doing passing values. It's passing values into the function via the parameter list. This parameter list can have 0 to many items in it. If there's more than one item in it, you use a comma to separate. This will make much more sense once we start writing them. I promise. Another one does the same thing. This is called the function body. The directions are the body. The top line is the definition. Why am I telling you this? Because vocabulary shows up on all your tests. And guess what? you got another test coming up next week. There will be a test next week. You'll have all week to pick your day to take it, but you'll have a test next week. Very similar to the test we took before. But if you run into code lines like that are messed up, send me an email where I can fix them. They're not supposed to be that way. So parameters help the function do something, so it's needed information. Now, draw a square. As long as it's this, you want the square to be exactly the same size every time, it doesn't necessarily need a parameter. But wouldn't that function be more useful if you passed in the size you wanted the square to be? And then instead of hard coding a number in, you just use that variable name in your forwards, and your square all of a sudden is variable, and you can use it for a lot of different things. Some of them return values. So I could have a function that does averages, and it could take the numbers as parameters, or it could take a list of numbers if you really wanted to get into that. And it could do the steps for computing the average. And then you use the keyword return. And whatever comes after the keyword return gets passed back to your code. And you can store it in a variable. Input is a function that returns a value. Every time you ask the user for input, and it returns something because we set it equal to a variable, right? If you don't set a function with a return value equal to a variable, or use that function's value in an equation as you're going along, the function still runs, it still returns it, but your program's going to garbage collect it. You didn't store it anywhere. So it did the calculations, and it passed it back to the main control unit, and then it dumped it. So you need to make sure that if you're returning a value, that you set it equal to a variable, or you use it instantly. I like setting them equal to variables as you're learning, because then you always have it if you need it again. So here's an example of that. This function, get distance moved, takes the size and the steps, and it returns the size multiplied by the steps, right? Did I really need to write a function for that? Probably not, but it's a good example. So it's going to return what the total is. So I need to set up a variable. In this case, we called it result. Result equals, then you put the function call in there, and then I can print out what result is later in the program. That makes sense? So I define what the function would do on the top, up here. Oops, go back. And then when I get to the second part, I put in real values. I called it with the values I wanted to compute. It does the math for me, stores it into a variable called result. And when I get ready to print result, I just call result. I see some crazy clicks. Yeah, go ahead.
Is the idea for this, say there's no stupid question, but is the idea for this, you mentioned getting the average, these functions. Is the idea being that eventually these can get highly complicated?
Yes. The idea is that you could do all sorts of math equations in your helper functions. And then you don't have, you get that working, that math always works. Every time you need it, you just call the function and return it to a variable. Or you have
That
some,
couldn't be done, I guess, by a simple average line of code.
you could absolutely do an average with a simple line of average code. But let's say you wanted to sort a list of 10,000 records alphabetically, and then use them.
So it's infinitely more complex.
It can get infinitely more complex. You can use a function to do the sorting, pass the sorted list back to do the next thing you need to do. So we're compartmentalizing things. This makes it much easier.
Kind of see how far it goes.
Yeah, it could be, it could have whole. Those functions that you call from here could call 15 other functions. So it could infinitely get more complex. What we're trying to do is help you build blocks, and this makes debugging your code so much simpler. Because if your functions only do one thing and do them well, you take the complexity out of where my logic would go. I'm gonna do the average here. I'm gonna do the mean, median, and mode and separate.
And if it's wrong, you only fix it once.
Then you only have to fix it once. Absolutely. So as long as the functions are working and you tested them, you can eliminate that from your logical errors later on because oh, this function works because I know because I tested it. So there must be something wrong with the equation that I pulled it into. So same thing here, different numbers. It returns values, you have inputs, it just lets you, anywhere you see a variable in a function definition, you can give it new information. Does this need to be bigger?
Probably. Not different, just bigger.
No,
And we go.
no idea.
And it's right.
It's, yeah. Don't touch the touchscreen computer, it does not work. All right, so. I know I've got a few of you confused, I can tell. The blank stares are telling me everything I need to know. So, questions? You want me to keep going and then hope it all pulls together and we start coding on Thursday? I got some nodding going on.
Okay.
All right. Sometimes I think I talk about this stuff too much and I over talk it, and that confuses you too. So tell me to shut up if you got it. So we imported modules, right? So we imported all their functions. So Alex can call all the turtle functions. You don't have to rewrite them. So that's what I'm talking about, reusable. We can use all of the functions that are defined in the APIs. The documentation on the Python page, all those functions have been written. All we do is import them and we use them. Now we don't have to write our own code for everything. That was absolutely fabulous, especially when we get to math functions, because I never can. Math. Don't make me think that hard. So we need to talk a little bit about scope of variables. So you know how when we're doing for loops and we create I only exists for the for loop. You can't use I somewhere else in your code. It just is the counter for the for loop, right? So that's a local variable that belongs to a for loop. So these parameter variables only belong to that function. They're defined with the function header. So in the last example, we did size and steps. Size and steps only exist for that function. You can't use those variable names somewhere else in your code
Because you already used it right there.
because they belong only to that function. If you use them somewhere else, your code thinks you're redefining them, and they don't mean the same thing.
If the built-in functions and everything, are you supposed to just know off the top of your head which ones you can't use, like steps, sizes, or things that
You can use them.
are not used?
You can use them, but once you put it into the function, it stays inside that function. And that's called scope. So we have what we call global variables. Those are things that are defined for the entire program. And then we have local variables, which are inside of functions or inside of structures like loops and if statements. And we have class variables. It just depends on who it belongs to. The scope tells you who the variable belongs to. So if it's defined in the function definition, it belongs to the function. If it's defined in the top main of your program, it belongs to the program. That makes sense?
Yes.
Can you repeat variables? Yeah, don't do it. You could, don't do it. You could have a local variable and a global variable that have the same or similar names. And the computer will keep up with which one needs to go where, but you won't.
This is a situation where Python will let you do something like that and get away with it. but
Yes.
they're not.
Some of the others will let you get away with it too,
Also,
but this is when you need to clearly define your variables. Always. So A and B are local variables. They belong to the function. So if I had all of this code written in my program, I have a function definition, then I have A is equal to 3 and B is equal to my func A, comma 4, print A. A is 3. So I put 3 here, I have a 4 here. A is 3, so 3, 5. So this A belongs, and these two A's are the same A, but this A is a different A. Don't do it. Use different variables, right? So the A down here, A is equal to 3, belongs to the program because it's not in the function. But the A in the parameter list belongs to the function. Don't do it. Use different variable names. Will it work? Yeah. Don't do it. Just you can have as many variable names as you want to. Make your own variables. Don't use A, B, and C. Make them useful. All right. So there's a special function that we all need to know and love. It's called main. Main is the driver of your programs. Right now, we've just been running code, and the compiler has been doing it for us and not been unhappy about it at all. But if you want an application that you can actually give to somebody and it runs, it needs to have a main. Because they may not have idle on their machine to do everything for them. So from here on out, code you write for me in idle will have a main method or a main function. All of them will have a main. It will have a main, not 3. One main method per program. Right? 1. So if you've done it correctly, the program will start because it's a call to main, and main will drive the program to completion. So this is what it looks like. You'll have at the top, and I like to see your main methods at the top of your program. Why? Because you don't forget them that way. They're easy to find. Can you put it somewhere else? Yes. As long as it's defined before the end of the program, great. So this defines your main, and it always looks like this. It's DEF main, open close parentheses, colon. You don't give it parameters, it's just main. And then you could put in commands to do in main. You can call other functions from main, but main's going to drive your program. Make sense?
Is it itself a program?
It itself is a function, which is why the very last line of code in your file will be a call to main,
To run.
which makes it run. When you double click on the file, it runs. So you see, I left a lot of white space in between the definition and main. So what I usually do, because I tend to forget things like the call to main at the end of my program, I usually write the main function, just an outline of it, doesn't necessarily have anything in it, maybe a print line that says, this code written by Tracy Wilson. And then I hit enter 5 or 6 times, put white space in there, and then I put the call to main, is just main, open, close parentheses. And then all new code I write, every function, every line of code I write from that point on, goes between those two things. All new code goes before that last line. Make sense?
Creating space to work with.
Yeah, I create a blank space to work with, tell myself to go in there. Why? Because I can't tell you how many times I have written code and I go and I run it and it doesn't do anything. And I'm going,
What makes it seem like more like a page you're writing?
Yeah,
You can see the top, you can see the bottom.
if you've ever written HTML code, you can think of it as you have an opening and a closing condition.
There's a sense of order.
Yeah, everything has order in computer science. Now, does the main have to be the first thing? No. It could be the last thing, you define, be the last function. But my coding style, and I'm the person grading your coding style.
Is it common to do that? For you, not just for you?
Yeah,
Is that acceptable?
I find that most people either put main at the top or they put main as the very last function. And it just depends on who taught them the code.
But
Like,
that would be-
It doesn't matter because the last, as long as main, the call to main is the last line and everything else is inside of a function, it will go there first.
Fair enough.
Now, we're going to talk a little bit about something I call orphan code. From here on out, you should not have random lines of code that are not inside of a function. At the very least, they should be inside of the main. There should be a random print statement, not connected to a function. That makes sense? You'll see when we go along. Python will let you do that. They'll let you just put like random lines of code that run.
That's things like-
Yeah, it can. I feel like I did this one already. I have done these already. Oh. Okay, that one's due. So we're talking about, let's talk a little bit about documentation. I've been having you do comments. You've been doing single line comments, right? The little pound sign and the words are comments. If you want to use something called doc strings, these are multi-line comments that can be collected at the end of your program into a document to help build the documentation files. Every function, if you're following the coding style, should have doc strings that tell me what the function is supposed to do. In theory. And this is also a great place, but I worked on this really hard and this is what I intended to do, but it's not quite doing it. Can you help me? Kind of comments to get partial credit, right? But doc strings start with 3 quotation sets of double quotes and they end with 3 sets of double quotes. And if you do that, the compiler ignores those lines. They're just comments for me and you to read.
Like get rid of entire paragraphs of code.
Yes, these are absolutely fabulous things when you're debugging code too. Yeah, put them at the start of where you want to ignore code and put them at the bottom. You know, and then you can pull whole pieces out. But okay, so let's see if it works without this.
I've had entire sections up on the
Mhm.
phone. And it was.
I do that all the time. I comment code out all the time to try to isolate where my problem is. I've been known to comment whole files out and uncomment it one line at a time until I find the problem. Now, there's a style guide. If you guys are interested, there's a link to it in the slides. This gives you some ideas of what is considered acceptable style. layout, indentions, tabs and spaces. There's a lot here. The only person's style guide that really matters at this point is mine. It's mine because I'm the one grading it. I do try to follow these, or I try to follow the departmental style guides. Remember, use the tab key, not the space key when you're doing your indentations. Use all lowercase letters for variable names. I prefer the name to be at the top of the file. These are styles, not set in stone. Program still works. But if you get a job in the real world, they will absolutely have style guides at your employers. If they have been doing coding for any length of time, they're not a new upstart, they're going to have a style guide. Because they want to be able to read your code and do something with it when you move on to bigger and better things.
They want it uniform.
They want it uniform for the next person. And they want to be able to pull those doc strings out to create the documentation files and the user guides. So, generally speaking, if you get a piece of paper from me that says, project 2, this is what you need to do. Generally speaking, functions are the verbs. They're the actions that the nouns need to be able to do in that. Yeah, look, I brought English into computer science. You all hate me now. But if I gave you something that says, create a program where a turtle needs to move and turn and draw. Well, functions are going to be that move, turn, draw, because those are verbs, those are actions and things that it needs to do. And the turtle is the thing we need to construct, or the object we need to make it work. Does that make sense? When it applies to anything you're simulating. Say I need to write a point of sale program for a restaurant. Nouns, customer, server, cook, actions, take order, pay server, cook food. So, right? So there's functions or actions that the cook needs. There's functions or actions the server needs. There's functions and actions that the customer needs. This is why I think computer science is great. You can simulate just about anything in your real world in a computer program. It's very creative.
Including the world.
Including the world. You can create a world. So nouns or phrases are going to be your variable names or your objects. Functions are going to be your actions. That makes sense? We talked about scope already. Don't repeat yourself. You're going to hear something called the dry principle over and over and over again. If you're repeating code multiple times, like you're writing the code to draw a square 3 or 4 times in a program, that's when it's time to pull it out into a function. If you're doing the average of numbers over and over again, create an average function and pull it out of your code.
Is that what happens? Just realize you're doing it again.
Yeah, usually you figure it out. Usually you're like, I've done this 2, 3 times now. Maybe I should make a function out of it, refactor my code, and just use the function call instead of all these lines of code. And then it's not, instead of it being hundreds of lines of code to read, you can then sit down.
But not doing that is a problem.
It's
When read later by someone.
Yeah,
It's
frowned upon, or they'll go, they're new, they don't know what they're doing, they wasted a lot of time. Sometimes you'll hear it referred to as spaghetti code because it's all over the place. So don't make extra lines or extra noodles if you don't have to. You're also going to hear about single responsibility principle, or SRE. That means that your functions should do one thing. If I have a function called draw box, it should not draw a box and a triangle. It should just draw the box. If I have one that says get average, it should just do averages and not give me the average and the standard deviation. Does that make sense?
Yes.
We are going to do, your lab is gonna have you draw on the bus. We're gonna step up to it. But we're gonna build functions for the bus body. We're gonna build functions for the windows. We're gonna build functions for the tires. You're laughing. I am completely, utterly serious.
Going on with us.
No, because they're gonna be just functions, not files. The functions are all gonna be in one file. You're gonna use a lot of lines of code. Gonna use a lot of lines of code, but we're gonna enjoy it. I'm gonna help you. Helper functions help get something done. So like what that goes back to my explanation. I need to sort 10,000 records into a sorted list. That would be a helper function. It's gonna do the sorting for me, give it back to me where I can do what I need to do.
But he's over like. Nested is up there, right? Are they
Yes.
inside the?
You can nest them inside of other functions, absolutely. They don't happen to anybody. They usually are, but they're helper functions. You're usually using them to do something else. I feel like those slides got repeated a lot. I don't know. I'll figure it out. All right, questions? And I confused you and thrown a whole lot of data at you today. A lot of terminology. Hopefully that will help you when you start doing the challenges in the Zybook, because I think I've covered most of the big terminology for you. On Thursday, I'm going to pull up kind of a mini lab. And we're going to do it together. So you can see how all this pulls together. We're going to write a main. We're going to write functions. We're going to, write helper functions. We're going to do stuff like that. And then Friday, I'll answer some more questions. You'll have the weekend to look at the lab on your own. Monday and Tuesday, you can email me questions before you have to turn in on Tuesday at midnight. So the plan? If this strategy doesn't work out and it's a complete disaster, we'll try something else in a couple of weeks after you do the project. All right, I'm done. If you are done, you're welcome to leave. If you have questions, I'll stick around for a few minutes.